Let's solve the equation the square root of x plus 1 is equal to 3. We call this a root equation because it contains a square root. The strategy to solve this is pretty straightforward. What we're going to do is take the whole equation, the square root of x plus 1 is equal to 3, and we're going to square both sides. So we're doing the same thing to both sides of the equation. If you square a square root, they completely cancel one another, and you're left with just x plus 1. And if you square 3, you get 9. So this is our general strategy for solving something that contains a square root. If you see a square root and you want to get rid of it, you can square both sides to do so. Anyway, we have x plus 1 is equal to 9, and if you subtract 1 from both sides, you get that x is equal to 8, and that this is our solution to the original equation. I want to check to make sure that this is true. So I want to check to see if x equals 8 is actually a solution. If I put it into the equation, in place of x, we get the square root of 8 plus 1 is equal to 3. Is that true? Well, the square root of 8 plus 1 is 9. And then the square root of 9 is equal to 3. 3 equals 3 is definitely a true statement. And so, yes, x equals 8 is a solution to the original equation. Now, there's one thing to look out for. This strategy, it's really nice in canceling the square roots, but a problem is it sometimes introduces extraneous solutions. They look like they're solutions, but they turn out not to work in the original equation. Let's try it out here in something really similar. The square root of x plus 1 is equal to negative 3. So again, I'm going to start the same way by squaring both sides. So we'll start there. I have the square root of x plus 1 is equal to negative 3. If I square both sides, on the left, I get x plus 1. There's nothing wrong there. If you square a square root, they cancel to give you just what's underneath the square root. And on the other side of my equation, if you square a negative, it becomes positive, and you get positive 9. And if you subtract 1 from both sides, we end up again at x is equal to 8. Now, is x equals 8 a solution to this equation? I'm getting a feeling like it's not going to work, but let's just plug it in and see why. If I put 8 in place of x, I get 8 plus 1. So then I have the square root of 8 plus 1, which gives me 9. The square root of 9 is equal to positive 3, and it's false. Positive 3 does not equal negative 3. This means that x equals 8 is in fact not a solution to this equation. So basically, this process, what it will do for us is give us solutions, but potentially it might give us too much stuff or things that don't work. And our strategy will be to plug them in to see if they work. If they do, we keep them. If they don't, we just exclude them in our answers. So let's try this strategy in a different example, maybe one that's just a little bit more complicated. So here we have the square root of x plus 2 plus 3, which is outside of the square root, is equal to x minus 1. To use the strategy that we just did in the previous examples, we have to solve for the square root of x plus 2. We got to get this piece by itself before we square both sides. And to do that, I'm going to subtract 3 from both sides of my equation. So this is like where I'm starting. Take 3 from both sides. That gives me the square root of x plus 2 is equal to x minus 4. Once you have the square root isolated, it's now where you can square both sides and go from there. This side, the left side, simplifies very nicely. The square root and the squared cancel, and we're left with just x plus 2. On the right side, we're squaring x minus 4. And I want to be a little bit careful here, so I'm going to do this off to the side. X minus 4 squared means x minus 4 times x minus 4. That's x times x, which is x squared. And then we have x times negative 4, which is negative 4x. If I distribute in now the negative 4, I get a second negative 4x. And then negative 4 times negative 4, okay, that's a positive 16. If you square x minus 4, what you're left with is x squared minus 8x plus 16. So I'm just going to copy that down on the right side. X squared minus 8x plus 16. So what we just did is we took this root equation, squared both sides, and now the roots are gone, and it's just a equation with an x squared term in it. And we have strategies for solving this type of equation. What we're going to do is subtract x and 2 from both sides so the left side's equal to 0. So that is, I'm going to subtract x. I get 2 is equal to x squared minus 9x plus 16. I'll then subtract 2. And I have 0 is equal to x squared minus 9x plus 14. So to solve this equation, what we're going to do is factor it. Wherever each factor is equal to 0 is potentially a solution to our original equation. So let's see. I want two numbers that multiply to a positive 14, yet add to a negative 9. They both have to be negative. Two negatives multiply to a positive, and they would add up to this negative in the middle. Let's see. Okay, 2 and 7 seem to work. Negative 2 times negative 7 is a positive 14. The sum of those two things is negative 9. This means my two solutions are, looking here, if I put 2 in place of x, I get 0. And then looking here, if I put 7 in place of x, I get 0 as well. Nice. So x is equal to 2, and x is equal to 7. The only potential issue is that maybe one of these, or both, are extraneous solutions. Maybe they both don't work in the original equation, so I'd like to check them. Let's start by checking 2. So I go back to my original equation, and I'm going to put a 2 in place of every single x. I get the square root of 2 plus 2 plus 3 is equal to 2 minus 1. Square root of 2 plus 2, that's 4, plus 3 is equal to 2 minus 1. Square root of 4 is 2. 2 minus 1 is 1. Okay, this is not going to work. 5 equals 1. That's false. Since none of these are true, it must be that x equals 2 is not a solution. So that one's extraneous, doesn't work. But if we check 7, okay, let's see, we get the square root of 7 plus 2 plus 3 is equal to 7 minus 1. That's the square root of 7 plus 2 is 9. 7 minus 1 is 6. The square root of 9 is 3. Oh, okay, this works. 3 plus 3 is 6. 6 is equal to 6, so this is good. X equals 2 is a solution to the original equation. In fact, it's the only solution to this equation, and that is it for this example.